Hi there. We're going to look at some SFIC picking analysis. That's small format interchangeable core, which is SFIC picking analysis. So I did this study because I wanted to see why are some SFICs easy to pick and others or not. Okay, here we have a small format interchangeable core in a mortise cylinder. We're looking right down on it. See the typical figure 8, and beside that we have a control key. Note the C on the symbol and an operating key. If you observe it, notice that those are the A keyway, which is the most common keyway. Now we have the small format core coming out of the mortise cylinder. Notice that I've put in the control key and partially withdrawn the SFIC. I put this slide in here because this is a very useful tool if you're going to disassemble a small format interchangeable core. This is the part number. It's made by Lab and it's called the I-Core Annex. This is a view of the I-Core Annex. There's the big block on the left, which is the main body of the tool. I have our core, small format core, partially inserted in the block, the Lab Annex. And down on the right is the code book. This code book goes in the bottom of the main steel block. And when you eject the pins through those little holes, you get all the pins into the code block. That way you can see what the pinning of the core is. Now I just showed this slide just to show you there's an ejector tool. The core is all the way in the annex, and I'm going to push out all the pins into the code book. So here I've ejected all the pins in the code book. The core is now empty, and I pull it back out of the annex. This is a recreation of the code book contents. I've actually discarded the springs and the caps, and I've flipped all the pins over, and I've used brand new Lab pins so that we can see it more clearly. Okay, this is a view of all the pins. These are brand new Lab pins in the control code book. So I want you to notice here, I'm going to use the laser pointer. So notice that the stack heights in each chamber are all the same. We can go down and look down here. This number 1, this indicates this is chamber 1, chamber 2, chamber 3, 4, 5, 6, and 7. If you had a 6-pin lock, it would be only numbered 1 through 6. Because in the case of best locks, chamber 1 is at the rear of the lock. This is chamber 1. It's the tip of the key. This is chamber 2, chamber 3, chamber 4, 5, 6, and 7. But the stack height, see, this is all of these have the same height, so that any spring above or cap to hold the springs in place would maintain an even pressure across all the pins. Now going further in arrangement, I've arranged the pins. I've done that with some tweezers to make them all at a specific height. So I'm going to use the laser pointer here. Notice that these are all here raised to this, what we call the operating shear line, because these silver pins all along here on the bottom are the actual key pins. They're nickel silver, and that's the standard for small format cores for less key wear. Above that are the top pins. Here's 2 pins, 2 pins, 2 more pins. Notice that there's 2 pins above each key pin, and they're just plain old brass. Now here I've arranged the key pins so that now we're at what they call the control shear line. The pins are raised to different heights than they were in the last slide. You probably can't remember, but this is different heights. So we put a key in here and raise these up to the control shear line. These pins, these middle pins, are called the control pins. Now I've taken a crappy photograph and I made a bunch of markings on it. Here in this case you can see I put all the pins at the control shear line, and I made a bunch of notes and all this stuff on here, which doesn't make a lot of sense, but that's not important. We're going to be looking at the next slide. Now this is the real meat of the presentation. Here I had my friend Josh take the graphic information that I hand drew and wrote and put it overlaid it onto the picture. So notice here, this is called control. So this is actually a picture with the graphics of the control shear line. This is the control shear line along here. But I want you to notice we're going to look at some specific things in this drawing. See, if you look down here, chamber number 1, chamber number 2, 3, chamber number 4, 5, 6, and 7. But notice here we have a number 4 key cut. He's drawn this key, what the key would simulate to lift it to the correct bittings. See the root depth here? This is the actual height that the key cuts are made from the bottom of the key. So in this case here, a number 4 key cut raises the pins up to 268 thousandths. So the control key is a 4, 7, 3, 2, 5, 6, 7. So now that we've looked at that, let's look at the key pins. This is a number 3. It says 3A. It's 147.5 thousandths thick. Above that is an 11. Notice it's an 11B in order to specify them as top pins. So the letter A means it's a key pin, and you can see them, they're silver in color because they're nickel silver, made for better wear resistance. Now these are brand new pins from lab. I put them in here because they're nice and clean and clear, and that's the way they're made. So in this case, we've arranged all the pins along the control shear line. See the control shear line right along here. So we've had to lift the key pins up to a 4 to bring it up to the control shear line. And in the second chamber, we brought it up with a number 7 cut, to bring it up to the control shear line. And here in chamber 3, we use the number 3 cut to bring it to the control shear line. That's and here a number 2 cut on the key in chamber 4 brings it to this control shear line. Likewise here, a cut 5 of the key, see this is the key profile, brings this pin stack to the control shear line. Here, chamber 6, we have a 6 key cut, and it brings it to the control shear line, lifting all the pins to the control shear line. And here on this control shear line in chamber 7, we have a number 7 cut at 230.5 thousandths. So now that you've seen most of the information along here, I want to point one other thing out. Let's look at this pin here. See this pin here, a number 10B. So notice that this is 125 thousandths inch. This specifies how tall this pin is, how thick it is. But notice that the control shear line, this is a distance between the control shear line and the operating shear line, is 125 thousandths. That's the exact same number as here. That's 1/8 of an inch. So the distance between the control shear line and the operating shear line is 1/8 of an inch. So if we had a number 10 key pin in place here instead of this number 11, we would actually arrive at both the operating shear line and the control shear line at the same time. But in this case, we've picked to the control shear line. We haven't got to the operating shear line yet. So this is going to be the first click on this chamber. So now we're looking at the operating shear line. Above, we've labeled this as operating, as opposed to the other one said control. So here, let's look at chamber number 1. We have a number 3 key cut. Remember, we're looking at the key cuts all along here. This is a different key than the control. So in chamber number 1, we have a 3 cut on the key, and we have a matching number 3 key pin. This is a number 3A. Remember, A is the designation for the key pin, and B's are for the top pins above the key pin. So in chamber number 2, down here, we have a number 8 key cut with a number 8 key pin. Likewise here in chamber 3, we have a number 8 key cut and a number 8 key pin. We can do the same over here. In chamber 4, we have a number 5 key cut, and we have a number 5 key pin. Well, you notice, of course, how these match. That's correct. So a number 2 key cut, we need a number 2 key pin. In chamber 6, we have a number 3 key pin, and we have a number 3 key cut. Chamber 7, same thing, a number 6 key cut with a matching number 6 key pin. So that's really the way that this is made, the way it's pinned up. I want you to notice something else here. I'm going to turn on my laser pointer again, and at number this here, this particular pin is a number 10. It's 125 thousandths, 1/8 of an inch tall from here to here, 1/8 of an inch thick. But notice over here, the control shear line from operating to control is also 125 thousandths, 1/8 of an inch. So if we had this number 10 key pin over here in this particular spot instead of this 11, then we would have the key cut raising the pin to both the operating and the control shear line at the same time. But in this case we don't. We have a number 11 here. So in this case, if we lift this pin, we're picking the lock, we lift this pin here, number 3 pin, up, we hit this operating shear line. Secondly, we're going to hit this one first. But notice in this chamber, chamber number 2, if we lift this pin up, we're just picking it, we're lifting it up. What do we hit first? What's the first click? That's this click right here. We're on the operating shear line. So if we look at chamber number 3, an 8 key pin, we're lifting it up with our picking tool, and we hit this shear line first. So that's the first click. But over here, we also have done the same thing. In chamber number 4, we've hit the operating shear line before we've arrived at this shear line. But in this case, in chamber number 5, notice when we're at the operating shear line, we have already passed the control shear line. So this is going to be like the second click. So if we're picking this chamber, it's not likely that we're going to stop right here. We probably would stop right here because that's our first click. And we have the same thing in these last chambers, chambers 5, 6, and 7. To arrive at the operating shear line, we have to go lift the pins higher than the control shear line. So only in these 3 chambers, chamber 2, 3, and 4, have we struck the operating shear line first. In this chamber, chamber number 1, we've passed the operating shear line. And the same thing over here in chamber number 2, we've passed the operating shear line, or excuse me, passed the control shear line to get at the operating shear line. Now we can put these both in the same screen. We have the control here and we have the operating here. But it makes it kind of hard to see because everything got really fine and detailed. But it's the same 2 slides. Same 2 slides. Here's the operating slide and the control slide. But let's go over and look at one of the individual slides again. So now here we're looking at the operating shear line, where the pins are set at the operating shear line. Now I just want to talk a little bit about small format interchangeable core pinning. Notice on this slide we have all chambers have 3 pins. Now if this was a master key lock, it would have 4 pins in each stack. It's possible, but extremely rare, to actually have 5 pins in each stack. This would mean that we've master keyed the control key. Now this is very rare, but it is possible to master key, have 2 different keys that would operate the control key or the control shear line to remove the core, but there would actually be a master key. So that is extremely rare, so you would probably never see that. But you will expect to see maybe 4 pins in a stack. Let me put on the laser pointer. See, here we have in chamber number 1, we have 3 pins in a stack. So this lock is not master keyed. But the main point that I want to notice is that when I raise everything, pick the pins to the control or to the operating shear line, which is shown here, it's not the same pins as in the operating, as in the control shear line. Some of the pins are above and some are below. So when I'm in operating, only the operating shear line will open the cylinder, and it would not just as well open the control shear line. If I had this pin in number 10 over in this position here, then the control shear line and the operating shear line would be at the same height, so that chamber would unlock both the operating and the control shear line at the same time. But of course I have all these other pins that would prevent that from happening. So what I see in a lot of cases is that there are a number of chambers that have both, that have this number 10 pin and the center pin, or 2 master pins that make up an 1/8 inch height that would operate both the shear lines at the same time. So that makes it a lot easier to pick. If you just pick and you get 1 click and it runs the operating shear line and the control shear line at the same time, then that makes it a lot easier to pick. But in this particular case, notice we have a 3, 8, 85236, which is not the same as the control shear line. Here, if we look at the control shear line, which is up here, the control shear line, anyway, the key cuts are a 4, 7, 3, 2, 5, 6, 7. So that's the cuts you need on the control key to raise it to the control shear line. Now the point is that the control shear line, the key that raises it to the control shear line, is a completely different key than the operating key. So what you have is two independent locking systems that are unrelated to each other. So you have a locking system for the control shear line, and you have a locking system for the operating shear line. However, when picking, since both these control cuts to raise to the control shear line and the operating cuts of the key, they're in the same pin chamber, you have interacting pins. So that is the reason that it may be difficult to pick this lock. So now let's consider picking this lock. We're going to look at chamber number 1 here. We put them both together. May be difficult to see the graphics, but that doesn't matter. What we're concentrating on is we're going to lift this number pin. We're going to lift the front pin, which in this case is called chamber 7, because that's the best way that they're numbered from the rear or the tip of the key to the bow. So we lift this pin up, well, here, but now look here. We're going to hit the control shear line first. That's going to be our first click. We have not got to the operating shear line. So click, we got a control. We go to this next chamber, chamber 6. Click, we hit the control shear line. Let's go over to the next chamber, chamber number 5. We lift here. Click, and we've hit the control shear line first. All right, so there we stop. Now we're not considering binding order or any of these other factors, grease and grime in the cylinder making it hard to feel the clicks or anything else. We're just looking at pins. So let's move on to chamber number 4. We start lifting, and what? Oh, wait a minute. What do we hit first? Here in chamber number 4. We hit the control or the operating shear line first. We have not hit the control shear line. We have to raise the pin higher to hit that. So in this case, these 3 pins were sitting at the control shear line because that was our first click. Now our first click is on the operating shear line in chamber 5. We look over at chamber 4. We look at chamber 3. Now we've hit the operating shear line first because here the control shear line is above. See, we get this. Here's the operating shear line for that pin, and we would have to go 2 clicks to pick up that pin to the control shear line. So we hit an operating shear line here, and in chamber 2 we've hit the operating shear line first. Now notice how close it is to hit the control shear line. In this case it's really close. It's only 12.5 thousandths. I could go into that detail because these are the pins and wafer segments are in 12.5 thousandths, but we always pin the lock 2 steps, so we pin it at 25 thousandths. So at 12.5 thousandths, the shear lines are too close. When we pick this up, what are we going to hit first? The first click is going to be on the control shear line. We have to go 2 clicks to get to the operating shear line. So the point here in this whole exercise was to demonstrate if you're lifting pins, you can hit different shear lines. So that makes it very difficult. Now consider if this lock was master pinned, we would have 4 pins in one or more of the chambers. So in some cases you might think that picking to multiple shear lines is easier. We have, like, that's true with a standard locks where we don't have we don't have 2 shear lines. You can pick with a master key. It makes it easier to pick, but here it can actually add confusion because let's say if this pin here was split in 2, this number 11 pin had a number 4 and a number 7 with it, that would make 11 total. Then they would have actually more shear lines in here. So it's not necessarily that it could be at the control, but certainly we know we're not going to master pin the control shear line we're going to master pin the operating shear line. So that gives you a lot better chances to hit the operating shear line. But in this case, you could hit the control shear line first. So the whole point of this exercise was to talk about why some are easier to pick than others. Well, if I talked earlier where I had this number 11 pin and I had a number 10 pin here, where the control shear line and the operating shear line were identical. I've seen that in many cases. So when you get one click there, you've got both the shear lines together. So that makes it essentially only 6 other chambers that you have to pick. In a lot of cases, I've seen three or more chambers that actually have the same shear line for both control and operating. So that makes a lot easier pick. But in this case, all 7 have different operating shear lines for both the control and the operating. None of them are in common. So this lock is going to be a lot harder to pick than locks that would have the same key bitting that would operate both the control and shear line in one chamber. It won't open the lock to either one. I mean, if you pin the chambers, all the chambers with the same bitting for both control and operating, then it really wouldn't work very well, because you turn the key and the control lug tries to retract and the key tries to rotate and it would be a big mess. So we don't do that. So the whole point was trying to understand why it's easier to pick some locks than others. Well, some are picked with common chambers that have both the same key lift, the same key cut that operates both the control and the operating shear line. But in this case, none of them do. So this lock is more difficult to pick than most. And if it's master keyed, then there's more shear lines. But remember, those shear lines will all be in the operating shear line. So that's really where I wanted to go with all this. So I wanted to say thanks for watching, and please leave some comments. So this is like open for discussion on thoughts or insights. To continue with this discussion, I was just trying to do an exercise to see why some locks, SFICs, are easier to pick than others. So thanks again for watching.